Alright, so in 8.4, you guys learned how to multiply and divide rational functions. And 8.5, this is where you're going to just do the other two operations. You're going to be adding and subtracting rational expressions. What you want to keep in mind is these, rational expressions or rational functions are fractions. So how do you add or subtract fractions? Well, the steps for what we're going to do is you have to find a common denominator. So it just goes back to what you know about fractions, and then you actually do the addition or subtracting. Now, of course, this is going to be a bit more involved than just your simple fractions you guys have been doing, but we just apply the same idea because we're just adding fractions. Here's just more of a simple example. I just wanted to show you so you could look at, here we're adding two fractions. The denominator over here is a 3x and here is a 5x. So when you're adding two fractions together, you want to keep in mind that you want these denominators to be the same. So if I look at what they both have already, this one has an x and this one has an x. So they're set with having an x. They both have an x. Then I see that, this first one has a 3, which means, all right, I need a 3 over here. So if I multiply the bottom by a 3, now both of my denominators have a 3, which means if you multiply the bottom by something, make sure you multiply the top. And then this fraction on the right has a 5, which we don't have over here on the left. So if I multiply this one by 5 on the top and bottom, now do we have a common denominator so that we can do this addition? So let me rewrite this. Our first fraction, we have that 5 times 6, which will be 30, over, now our denominator is 5 times 3x, which is 15x, plus our second fraction, the 3 times the 3 is 9, over 5x times 3 is 15x. So you can see we have a common denominator, so we can go ahead and do this addition. One thing to keep in mind when you are adding or subtracting fractions and you get that common denominator, the common denominator stays the same. So I already know that's going to be a 15x. And then all I'm going to look at is adding the 30 plus the 9. And 30 plus 9 is 39. So we added the two fractions together. We got a 39 over 15x. What we want to think about here is, can we do any simplifying? Will it reduce? 3 goes into both of these numbers, so I can kind of rewrite this as a 3 times a 13. And down here, this is a 3 times a 5x. This is just another way to think about how you do your reducing. These 3's cancel, and so I'm left with 13 over 5x for a final answer. Here's a pretty similar example. One thing why I wanted to show you this is because when you get a common denominator, you want to think about it being the least common denominator. So we can see right here we have an x, and here we have an x squared. Now an x squared is an x times an x, which means I really have two x's over there. To work on making these denominators the same, well, I would need an x on the top and the bottom over here. So now they both have the x and the x. Well, they both have two x's, actually. And then you look at your numbers. I've got a 3 over here, which I don't have over here, so I have to multiply this by a 3. And then we're missing a 5 on the other side. So when you kind of build up your fractions to get a common denominator, it is always multiplication that you're doing. So our first fraction, if we go ahead and multiply 5 times x times 6, we have a 30x over, and then our denominator, 5 times x times 3x, is a 15x squared. Now, it's tempting to look at this fraction and say, okay, let me reduce it right now. But if you reduce this fraction, you're not going to have a common denominator any longer with our second fraction. So don't do any reducing, just leave it as it is. I'm going to bring down my plus sign. And then look at my second fraction. In the numerator, we've got a 9 over a 15x squared. So your denominators are the same. It stays the same. I know that 15x squared goes here. And then all that we're going to do is take that numerator and do 30x plus 9. So here's how we do simplifying of these. it's tempting to say, hey, I've got a 30x and a 15x squared, and let me go ahead and cancel some things. I could, divide these both by 15 and end up with a 2, or the x's might cancel. The only time, what you want to be careful of is this plus sign right here. If you have a plus or minus, you can't just start canceling things out. You do need to separate it with multiplication before you can make something cancel. And what I mean by that is if you look at the 30x plus 9, we could factor out a 3, and we're left with 10x plus 3 over. So what I've done is I've factored out a 3, which separates it with multiplication from that 10x plus 3. And then in the bottom, I could factor out a 3. It's really the same thing as 3 times 5x squared. And now we can cancel those 3's. This 3 and this 3 cancels, and you're left with a 10x plus 3 over 5x squared as your final answer. So I know these are tricky and weird. It really just takes practice. So you want to make sure, take good notes in this video, and when you get to class tomorrow, really use your time wisely and make sure that we're working through these and just, trying to get this down. I would say 8.5 and 8.6 are the 2 hardest lessons in the chapter. So you want to, if you really can get this down, you're going to be good. Here's another example. I'm not going to go through the whole one just because you'll have you're going to have videos on the addition and subtraction, but I just want to show you what it's going to look like to create a common denominator. This x plus 5 in the denominator, think about that as a unit of x plus 5, and the x plus 1, think about as a unit. Because of this plus in here, it kind of glues those together. The x plus the 5 is one thing together. So when we go to find a common denominator, or to create a common denominator, we have an x plus 5 in the fraction on the left, which means on the right we need an x plus 5 on the top and on the bottom. So now both fractions have an x plus 5 in the denominator. If I see, are they common yet? Not yet, because we have the one on the right that has that x plus 1, which means we need an x plus 1 on the left one. So if you look at the denominators, you have an x plus 1 and an x plus 5, and here you have an x plus 1 and an x plus 5. So I'm not going to continue the problem, but that's how you kind of build up and get that common denominator. So watch the video on a specific example or two for how to work these out. Here's another example. Just something else you're going to have to be doing is if you have something that's factorable in the denominator, you are going to want to factor that out. You want to look at it in that simplified form. That's helpful because maybe you already have something common to the denominator that you don't see until we factor it. So right now, we're subtracting 2 fractions, get a common denominator. I can see that they both already have the x plus 2. So the only thing that we're missing is that x minus 2 on the left side. So let me put an x minus 2 here, again top and bottom, and now we have a common denominator. So if you ever have something that you can factor, go ahead and factor it out so you really can see how it breaks down, and then you would recognize, oh, I have an x plus 2 and I have an x plus 2. So to keep it in the lowest terms, the only thing we need is that x minus 2 in the right fraction. And then again, we would continue the problem, but there's another video for that. Alright, the last idea for 8.5 is something called a complex fraction. So the steps for simplifying a complex fraction, you're going to simplify to end up with, you want a fraction divided by a fraction. So I'll show you what a complex fraction looks like in a second, but just keep in mind I need to simplify it so I have one fraction on the top and one fraction on the bottom. Once you have that set up, then you can divide fractions. And just, as a reminder, to divide by a fraction, we multiply by its reciprocal. It's that whole flip and multiply the second one. Here's what a complex fraction looks like. So it's complex. You've got a lot of fractions within fractions. Keep an eye out for the main division. you know, I can see we have divided by, divided by, divided by. But really, this divided by right here, that's the main one. And so what your goal is, and again, there's another video for this, so I won't go through this whole thing, but I'll just talk about it for a second. You want to have one fraction on the top and one fraction on the bottom. So you would have to simplify this and go ahead and add those two fractions together. So you're going to use the skills that you're building on how do you add fractions when they're rational functions, and you would get one fraction over here divided by, and then this is already one fraction, so you just bring that over there, and then you would have one fraction on the top, one fraction on the bottom. And then instead of doing this division, we would change it to multiplication and flip our second fraction. So a complex fraction just uses all the skills that you've been learning. You know, you're adding and subtracting fractions, and then you're dividing, which changes to flip and multiply. So, you know, work hard on this chapter, because when you get a problem like this, it kind of ties it all together.